Alright, we're going to continue our topic on circuit analysis. Last time we talked about Ohm's law and how to solve some pretty basic circuits using Ohm's law and its variations. We started with a basic circuit like this where you had some voltage source, you have some current, I source, going through some resistor. Now what happens when you use a device like a digital multimeter in the circuit? If I were to measure from this top point to the ground, measuring across the source, say it's a battery, the multimeter would read exactly what value the voltage source was. Now, it may not be completely obvious yet, but if I were to measure across from the same top point to ground, measuring across the resistor, I would get the exact same value as the voltage source, because these 2 points are electrically the same as measuring across these 2 points. If I have ground on both sides, you can think of them as being connected through the ground. So really, if you're measuring from the top to the bottom, it doesn't matter if you're measuring on the left side or the right side, you're still going to read the voltage source. Okay, so we're going to take this another step further, and we're going to draw another circuit that's very similar. We're going to have a voltage source, we're going to have a wire connected to a resistor, and then another resistor. And I'm going to label them R1 and R2. And I'm still going to have some source going through. Now, what happens if I measure across from the top to the bottom of this circuit? You would still see the voltage source on the left hand side, and you would still see the same voltage source on the right hand side, because again, these 2 points are connected. It doesn't matter if I'm on the left side or the right side, I'm going to see the same measurement. Now this allows us to do some pretty interesting things, because what if instead of measuring across both, I just measure across one resistor? I'm not in this case going to see the same source. I'm going to probably see something less than the voltage source. But this voltage plus this voltage will equal voltage source, because you're measuring off a section and then another section, but those 2 sections together add up to measuring across both of them, which we already discovered is the same as the voltage source. So let's go through one example of that. I'm going to again draw the circuit, and my source voltage will be 5 volts, and in this case I'll have one resistor and another resistor going to the ground, and this resistor will be 2 ohms, and this resistor will have an unknown resistor and an unknown voltage. This resistor, say we measure across it from here to here with a multimeter, and we see 3 volts. From this, we can use Ohm's law again. We can use V equals IR. We can use V over I equals R. And we can use V over R equals I. In this case, we know the voltage and we know the resistance, so we need to solve for the current. So we will use this variation of Ohm's law, and we'll plug in the values we see. So for a voltage across this resistor, we have 3 volts, and the resistor value is 2 ohms. So we find the resulting 1.5, and the units is current, so we say amps. So now we know how much current is flowing through this resistor. And we will say 1.5 amps. So now we can look at the second resistor, and it may not seem obvious at first that we can actually solve for any information. We only know the current flowing through the circuit is 1.5 amps, but we don't know the voltage and we don't know the resistance. However, we do know the voltage, and the reason why we know the voltage is because we have 3 volts, and we have that mystery voltage, I'll call it X volts, and we set it equal to something, and what we set it equal to is the 5 volts, because we know if we measure across both resistors, it's going to equal 5 volts. So I put 5 volts there. And then all we have to do is solve for the unknown voltage, and that's as easy as rearranging X voltage equals 5 volts minus 3 volts. It equals 2 volts. So we know that this voltage is 2 volts. And solving for the current through the circuit, now we know the voltage and we know the current, so we can solve for the resistance. And we can use this equation right here. So I'll rewrite the known values in this resistor is 2 volts, and we'll divide by the current, 1.5 amps, and we get a number, let's see, 1.5, I'm going to do long division, why not? We have let's see, 2 divided by 1.5. We have 1.5, we have 0.5, we do 3, and it's 3, 3, 3, 3, 3 repeating. And yes, I did cheat and just throw it into a calculator, but the resistance ends up being 1.33 ohms. So now we know the resistance equals 1.33. So we can say that this circuit is solved because we know all of the components, we know the voltages across all components, we know the resistance across all components, we know the voltage source, and we know how much current's going through.